Today I want to show you a few features of Brainspace that make it stand out as a product and as a nice add-on to our relativity offering. We provide full synchronization between relativity and Brainspace, so everything you tag in one syncs to the other, so that it can be used as an add-on as opposed to a completely separate product. So I'm going to go into some examples of how this can be used and how it's unique, and we'll try to do a little bit of a fun example here. So I'm going to jump into the interface. What you see initially in Brainspace is that it's very graphical. Today I'm going to focus specifically on how the machine learning component can actually help you find additional documents and then visually interact with them using the cluster wheel and the focuses. So I'm going to dive into that. Right now what we're looking at is the main Brainspace screen when you log into the case. And one of the issues that I had when I was trying to come up with a nice way of demonstrating supervised learning in an example data set like Brainspace is I don't have the full knowledge of the case. Even when I search for some of the key terms that are in the Enron database like Raptor or some of the other special purpose entities, it becomes very difficult to actually do a real review when you don't know what you're actually looking for in terms of a document. So what I decided to do was take a little bit of a different approach for the purposes of this demo. And what I found is that within the Enron environment, because it's people who are just sending emails around to each other, people do the usual things that they would do over email back at the time. This is 2000, 2001, and they would use it to send jokes. They didn't have Facebook back then. They didn't have a lot of social media applications. So email became this way of transmitting that type of information. And that I know how to review because I can identify something that's a joke. So what I'm going to do is I'm going to dive over here into my supervised learning, and I'm going to click on my joke classifier. Now, I've already done a little bit of training in the joke classifier, and you can see on the screen here that I've coded 33 documents. This means that I basically did a search for joke and some words that might appear in joke, and I went through and I decided whether some documents were responsive to joke or not responsive to joke, because that's something that's very easy to code, even if you don't know anything about the case. So what I did was I found 23 jokes, and I identified those 23, and I said, okay, I've got 10 that I think are not jokes. And so what I did was I ran that classification, and I had the system go ahead and build a training off of those documents. So this is your standard machine learning assisted review model. But what's interesting about Brainspace is that it actually allows me to go ahead and create a focus around it. So I'm going to jump back to my analytics section, and I'm going to go to my joke focus. So what does this joke focus represent? What I did was I took my machine learning and I said, okay, take those 33 documents that I've classified as jokes or not jokes and try to figure out what the universe of jokes is in my data set. And what it said was, okay, out of the 1 million documents that you have, we found about 4,360 documents that we think are actually going to be jokes. Now, I can actually go into them by clicking on Originals here, which will just show me examples of those documents. And at a quick glance, you can see, based on some of the titles, that these are in fact jokes. And I can see the time period in which those jokes were sent. I can scroll down and I can see some of the people who would send them. I can see top terms that are being sent back and forth in the jokes as well. What I'm interested in demoing today is something that is called the cluster wheel in Brainspace. So what I'm going to do is first I'm going to remove my joke focus so you can see what the cluster wheel would normally look like. Now, this may look confusing to people who haven't seen a cluster wheel previously, but what we're seeing here is essentially key terms that appear often in those clusters visualized. What is a cluster? A cluster is a group of documents that have similar language within their data set. So as I move closer and closer to the edge, so if you look at this graph here, you can see as I move out to the edge, I get more and more specific. So the middle is very general, and as I start moving out, I get more and more specific until the very, very edge is documents. So the documents live around the edge of the cluster wheel, and as you get closer to the center, you get a little bit more general. So in the center, we have very common terms, meeting, call, Enron, gas, things that appear a lot. But then if you look at the different sections, we can see market, energy, power in one section, or agreement, party, and contract in another, gas deal, total, daily price. You can see that these things have similarities within those sections, and they get more and more specific as you go out to the edge. So now I'm going to switch over to my joke focus, because now I only want to see those 4,000 documents that it thinks might be jokes. And the first thing that jumped out at me when I ran this was that it did seem to break this out into a number of categories. And if you look at the categories, you can see that we have some things that look like they might be jokes and some things that don't necessarily look like they may be jokes. So if we look at, again, the most general, we have asked, men, woman, wife, man, woman. And then as we move further out, we have husband, guy walks, which could be a guy walks into a bar or something like that. And other things that may be joke related. But if you look at some of the other sections, we have things like day and people, remember God, and love, remember life, people. What I realized when I started digging into this is that the language structure of a joke is similar to a language structure of an inspirational story or a religious inspirational story. And what was cool about this example was that Brainspace was actually able to identify not only jokes that were language structure jokes, but other things that shared a language structure to it. So it says, okay, these documents that you've tagged, they use language like this, and we've found ones that use similar language, but they might not necessarily be the category you're looking for. So if I were to dig into and click on this one, I can see that if I expand it, I have Jesus, Lord, love, Christ. These are religious stories. So I'm not specifically interested in those if I'm looking for jokes. The same thing if I go to this next section, and I can see that these are more about like hug, smile, love, life. This is inspirational stories. So they're almost like if you have a joke, it's similar to a story, but it has a punchline at the end. But somehow Brainspace and its intelligence has been able to kind of break these out into subcategories. So I know that this is actually the one that I'm interested in. And out of those million documents I started with, I said, okay, I'm going to code 33 documents. Some are jokes, some are not jokes. And then it says, based on the 33 documents you coded, we're going to say about 4,000 maybe in that category of similar documents. But then visualizing it and using these visualization tools, I can interact with that data and say, you know what, it looks like this cluster here with only the 1,112 documents are actually the jokes. So now what I can do is I can go ahead and add that cluster to my search and then start reviewing that specific group. So this makes it really easy to kind of have a general idea of what you're looking for, use the tool investigatively, and then focus in on exactly the sections of clusters that might actually benefit your review. We had a client who was reviewing in relativity, reviewing tons of documents, and was doing random sampling, was batching it out to people, and there were so many documents, and it was very difficult to find documents that were responsive. And they had been reviewing for days, they'd reviewed thousands of documents, and it came back maybe 1 or 2 documents were actually responsive and everything else was non-responsive. And they were getting very frustrated. They were using all the normal tools that they would use, like keyword search and concept clustering and things like that, without having to be able to actually interact with the data. So what we decided to do was we said, all right, let's take those documents that you found, we will find them in Brainspace, and let's actually go ahead and zoom in on the clusters that Brainspace thinks there might be associated with those documents. And we'll batch that cluster out, and you can do a more focused review. And within a couple hours, the client called back and said they found 15 more responsive documents when before that they'd only been able to find 1 or 2 within weeks. So it's a nice investigative tool that allows you to expand on work that you've actually done in relativity and use the visualization and investigative features to be able to go that additional step forward. We'll probably do a few more videos that show some other features, but this one talks about the cluster wheel and how that can be used to zoom in on your data. And if you want to use this as a test in your own workspace, if you want to bring your data into this environment and see how it can benefit you, let our project managers know. And again, it's completely synchronized with the relativity environment, so there's no processing, there's no additional loading that needs to go in there, and we can get it up and running pretty quickly.